What I'm showing is the RIGOL DSA815 spectrum analyzer hooked up to the RIGOL DSG3060 6 GHz signal source. As you can see, when I turn on the RF, we get a nice sharp signal on the DSA at 1 GHz. What I'm now going to do is, using the I-Q modulation function, I'm now going to change the baseband clock frequency, and I'm going to add that modulation first of all at 3 MHz. So I've now added a 3 MHz modulation. Now the span of this DSA is currently set to 200 MHz. So each of these half sections is 100 MHz. What I'll do now is to increase the bandwidth, and you can see the effect on the spectrum analyzer. I'll just speed up the trace a little bit so it sweeps more quickly. I've now increased the clock frequency of the arbitrary wave so that the skirt gets wider. As I increase it to about 10 MHz, it's occupying about 1 square. And now to occupy basically 20 MHz of bandwidth, I need a clock frequency of about 30 MHz. Now as I go up towards 40 MHz, you can see a really wide band of modulation. 45 MHz, that's now occupying 60 or 70 MHz of bandwidth. And as I go to 100 MHz, you can see the difference. That's 50 MHz clock frequency, and that's 100 MHz. So the nice thing about this is you can see the amount of modulation sidebands is phenomenal on this DSG, and it extends over the greater part of a 200 MHz span at 1 GHz. This DSG is capable of its center frequency being set to as much as 6 GHz. You can see that I'm adjusting the center frequency, and immediately the entire waveform moves around. It's also programmable, so you may be able to wobble the center frequency for various tests.